Hi everyone, welcome back to Made Easy Academia. Please don't forget to like our video, share so that other people too can benefit from these great tutorials that we are doing here. So now today we're talking about scalar and vectors. This is general. So today we'll be talking about scalar and vectors quantities. So in physics, what do we mean by scalar quantities? What do we mean by vector quantities? The scalar quantities are those quantities that has only magnitude but no direction. Just like the way we learn it when we are in secondary school, scalar quantities are those quantities that has only magnitude but no direction. For example, we have what we call scalar quantities. So are those quantities, if you check our materials, I'll break down the definitions so that you can see what we mean by that. Scalar quantities are those quantities that has only magnitude. They have only magnitude but no directions. So here, let me give a clear example. So let me just give a illustration. Imagine just like a distance covered by the object. Let's say we have a car that moves from point X. This is move from here, right, in the form of random motion, maybe from point X to Y, Z, W. As the car is moving, it doesn't have a specific direction. So the other one, when it has both magnitude and direction here, is called vector quantity. So for the vector quantity, are those quantities that have both magnitude and direction. You understand? So now, I will link it up together with the one that we have when we are in secondary school, so that you can have, because in this case here, we can use we'll be using like another direction like IGK as direction, but the one we learned in secondary school, we have like 4 directions. When we have like let's say we have something like this. If I have north, we have east, we have south, and we have west. This one is also another direction that we have. I just want to link them together. Please don't be confused about that. So now, an object can go either due north or due east or due south or due west. And it's a problem if you have to find the displacement covered by the object or total displacement covered by the object. So that's what we normally use what we call Pythagoras theorem. Do you remember Pythagoras theorem that we use? Please, if you missed our previous video, you can watch that one, how we use Pythagoras theorem. If I want to form, I can form a right angle triangle from this from this diagram. Either I form like this, or this one, or here, or something like this. So if you check material, you can see many definitions. I will just based on calculation aspects here. So like, for example, if I have something like this, if I label them, let's say we have A here, we have B, and we have C. You can see the longest side. The longest side of a triangle is called hypotenuse, as we know. This side is called the opposite, while this side is called the adjacent, right? So as we have this, we can use Pythagoras theorem. Maybe they said hypotenuse squared. Remember the formula: hypotenuse squared is equal to opposite squared plus adjacent squared. So it depends on the problem we are solving. So in some questions, it might relate for you to use this Pythagoras theorem. So please don't forget, in materials we see many definitions of how. I'm just going to base on the calculation aspects to save our time. So now, if you have this, you can use this approach also to find some problem. Maybe we have to find total displacement covered by the object. Let's see some examples of that. Let's see now some problems, and now how can we apply these scalars, and like this problem here. They said a dog walks a lady. A dog walks a lady 8 meter due north, and then 6 meter due east. Determine the magnitude of the dog total displacement. So let's look at this problem. Here they said a dog walks a lady 8 meter due north. You can see we are given direction here. So let's draw the diagram. We have something like this. This is north, this is east, this is south. At the same time, this is west, right? Now, a dog walks a lady 8 meter due north. So meaning it's going direction of north in form of 8 meter, then 6 meter due east. So due east is 8 meter. Then I said determine the magnitude of the total dog's displacement. So here I can just find the magnitude here, since what I have is north and east. Maybe we can have our direction here, the angles. So now I can use let's use R to demarcate the total dog displacement. So we call it magnitude. I have the diagram like this. So here I have R, I have 8 meter here, we have 6 meter here now. So recall, here is known as hypotenuse, here is known as opposite, here is known as adjacent, right? So if I apply the formula, I can apply the formula Pythagoras theorem, which is hypotenuse squared is equal to opposite squared plus adjacent squared. So now what we have for the hypotenuse is R. We have R squared is equal to what we have for the opposite is 8. That's going to be 8 squared plus adjacent is 6. That's going to be 6 squared. So now we have R squared is equal to 8 squared, and we have 64. 6 squared, then we have 36. So now we have R squared is equal to 64 plus 36. Of course, we are going to have 100. If I scroll the both sides, that means that we have R is equal to 10 meters. So it means the magnitude of the total dog displacement is equal to 10 meters. You can see that it's straightforward. Even I will be asked to find the directions of this particular object, I just apply. If you missed our previous video, if you watch that one, how we can use either sine or cos or tan. I can use sine here. The formula for sine is nothing but opposite over hypotenuse. So from the angle itself, the opposite is 8. And now we go this side to be 10 now. So I can just find the theta here to be sine inverse of 8 over 10 if I was asked to determine the directions. You understand? So here, if I got, okay, let me just find this one so that you can compare the result of what you have. Please don't forget about this. You can use either sine or cos or tan. I just make use of sine to save our time. If you like, you can use cos. If you like, you can use tan. The formula for cos is nothing but what is the formula for cos? Do you remember the SOHCAHTOA? Yeah, the formula for cos is adjacent over hypotenuse. So from here, my adjacent is 8, is 6, and the hypotenuse I have is 10. So that means I can have cos theta to be equal to 6 over 10. So since I'm looking for the theta, theta is direction, as I told you earlier here. So I can find the cos inverse of that. So, as I mentioned earlier, you can use, sorry about that. You can use any of these three. You can use either sine, you can use either cos or tan. Anyone you use out of the three, you can use that one to determine our theta. So meaning theta, sometimes they can call you'll be asked to find the direction. So theta is just like the directions. So here, that is 6 over 10 here. That is cos inverse of that. I will check that one. Shift cos inverse of what we are given there is 6 over 10. So when I press my own result here, what I have is theta equal to 53.13 degree. So if you check this also, we have to get the same thing. Shift sine inverse of 8 over 10. If I use that one too as well, definitely I must have the same result. So I have 53.13 degree. Or if you use tan, tan is nothing but tan is what? Tan is opposite over adjacent, and from this shape, our opposite is 8, and our adjacent is 6. So since I'm looking for theta, I can have theta to be tan inverse of 8 over 6. So therefore, if I find this, I will still have the same result. But you can see it lies within the north and east, right? So if I want to write the angles, I can just write theta is what we get is 53. That is north, 53-degree south. I hope you get it right. That's the directions. You understand? So let's solve one more question so that we move to the main other part that we need to talk about here. Let's say the problem says that a man let's say the problem says a man walks let's say 3 kilometers due, I want to just change it, due south, and 4 kilometers due west. They now said find the magnitude of the man's total displacement. So let's look at this. If you are going to get another result for this. So now, normally I will have to draw my shapes. This is north, this is east, this is south, at the same time, this is west. So they say the man walks 3 kilometers due south. This is south here. It walks 3 kilometers due south. You can see the first one is north and east, right? So it doesn't matter. So due south, then 4 kilometers due west. 4 kilometers due west. Then also find the magnitude of the man's total displacement. So here I can just like this magnitude, let's use m. So if I bring out the shape, it's going to look like this, but it's still right angle triangle. What I have here is 4 kilometers. What we have here is 3 kilometers. So here I have a still right angle triangle. It doesn't matter how they draw the shape, just follow it using the same process. So now, if I apply the formula, let's label the side. This side is known as a hypotenuse. This side is I can call it opposite. While this side I can call it adjacent, right? I hope you are getting it right. So fine. So using the formula is hypotenuse squared is equal to opposite squared plus adjacent squared. So what we have for the hypotenuse here is r. I can have r squared equal to what we have for the opposite is 3. I can have 3 squared plus what we have for the adjacent is 4. That is 4 squared. So here I can have r squared is equal to 3 squared. 3 squared simply means 3 times 3. Then we have 9. 4 squared, that one is 16. So by the time before we find that, so that means here I can have r squared is equal to 9 plus 16. Of course, you are going to have 25. If I square the both side, meaning my r is equal to 5 kilometers. So that means the total displacement of the object of the body is 5 kilometers. So you may be asked to find direction to just follow it the same process of the way I find it in the first example, so that you can be able to do that one as well. So now, instead of having this diagram, these directions, we make use of another way of representing vectors now, which is directions. We make use of for direction here, instead of using all those north, east, south, west, you're seeing them, we're using I, J, and K. So when you see these three, they are referring to directions. The particle have a direction I, or direction J, or direction K. It depends on the problem that we are solving. You understand, right? So now, but in this case, you may be asked to find, let's say, a particle, just like this one. If you check our material, you see how we Mark that just like something like this. New vector, let's say we have z here, let's go for k. So this is x, go for high, and this is y, this go for j. So this is what we have for this diagram. So now here I'll be using these vectors I, j, k to represent my direction there. So that one too is very simple. We can have addition of vectors, subtraction of vectors. So now, notice a vector, it must have directions. We will use of something like this or a bold one. If you see something like this, they're talking about vector because I told you that vector is a quantity that has magnitude. At the same time, they have direction as well. So we'll be using of a bold line here. So now, let's see addition and subtraction of vectors. It's very simple and straightforward. Addition and subtraction of vectors. Addition and subtraction of vectors. So note, we can only add two vectors together if they have the same directions or if they are the same. If they are the same, we can only add two vectors together if they are the same. For example, we say if, let me be using bold one. So in some textbooks or some materials, they can use bold lines, while some can use arrow to indicate that that thing is a vector. So here I'll be using bold lines so that you can see it's still the same thing. So if they say if A is equal to 2I plus 3J plus 5K, and you say B, please don't forget, they can put like this, it's still vectors. They can put it there like this, anyhow they put it. So you are using bold one here so that you can differentiate between the two. Let's say B is equal to 3I plus 5J plus 7K. They now say find. So we have to go 1A plus B. We have to go 2A plus 3B. We have to go 3. Let's say I want to find A minus B. We have to go 4. Even these vectors have from law like associative, distributive. If you check material, you see all those laws there. So now I was asked to find maybe 2A minus B. So I want to find the value of all these one after the other. So if A is equal to, so A is given as 2I plus, I told you I, J, K here, they are indicating directions, right? Good. So vector A is equal to 2I plus 3J plus 5K. Vector B is 3I plus 5J plus 7K. Now we have to find A plus B. We have to find 2A plus 3B. We have to find A minus B. At the same time, we have to find 2A minus B. So let's do it together, one after the other. The first one, I wanted to find A plus B. So don't forget, I told you they can put an arrow there to indicate the vectors. So in some textbooks, they use a bold one to represent the vectors. So I'm using bold one here. So now, vector A, if you look at vector A, is given as this value. I have 2I plus 3J plus 5K, right? Now, good. So now, vector B is given as 3I plus 5J plus 7K. So how are we going to go about this one? The next thing is, I will just match the one that have the same direction together. That is, I for I, J for J, at the same time, K for K. How? So down here, I can have A plus B equal to, now let's match them together, 2I plus 3I. Of course, if I have, I can only have the one that have the same direction together. 2I plus 3I, definitely, I will have 5I, right? Yeah, very, very nice. So 3J plus 5J, of course, we are going to have 8J, 5K plus 7K, we are going to have 12K. I'm just adding the one that have the same direction together. We can only add two vectors together if they have the same direction. So you can see here, I for I, J for J, at the same time, K for K. So 2I plus 3I, of course, we are going to have 5I, 3J plus 5J, we are going to have 8J, then 5K plus 7K, we are going to have what? We are going to have 12K. So now let's look at the second one. The second problem, they said 2A plus 3B. So here, meaning before we add them together, we should firstly use 2 to multiply what we have in A. At the same time, use 3 to multiply what we have in B. Then we combine them together. How? So here I can have 2 bracket my A vector A is this. That is 2I plus 3J, then plus 5K, then plus 3, open bracket. Vector B is this. That is 5i. Let me write it here. We have 5i plus 8j plus 12k. So this is what we have here. So now I want to open the bracket now. That is, I will use 2 here to multiply everything that we have here. I will use 3 here to multiply all we have here. So here I can have this one to be 2 times 2i. We are going to have what? We are going to have 4i. 2 times 3j. We are going to have 6j. So please, even some textbooks, they use a demarcation for it. Since it's a vector, they can use a demarcation for the direction as well. It's still correct. So please don't forget that. You can use something like this to demarcate that it's a vector. Maybe I should familiar with it so that you don't make any mistake there. So here, so now 2 times 2i, we have 4i. 2 times 3j, we have 6j. 2 times 5k, of course, we are going to have 10k. Then 3 times 5i, we are going to have 15i. 3 times 8j, we are going to have 24j. Then 3 times 12, we have 36k. You can see. So the next thing for me to do now is to add the one that have the same what? The same direction together. So here I can have 4i plus 15i. You know, I is for I, right? So 4i plus 15i, of course, I can have 19i. You understand? So now the next one is 6j plus 24j. Of course, I will have 30j. So 10k plus 36k, definitely, we are going to have 46k. So you can see that one is very simple and straightforward. So now, the next one we have to find a minus b. It's still going to be the same process. I was asked to find a minus b. I will follow the same rule, the same method, but the only difference here is that we are minus here, not addition. So here, a minus b. So a is 2i plus 3j plus 5k minus our b is 3i plus 5j plus 7k, right? So now, let's open the bracket of this one, meaning the minus that we have here must affect everything that we have in B. It will affect the first one, affect the second one, at the same time also affect the third one. So that means here we have 2i plus 3j plus 5k. Now, minus times 3i, we are going to have minus 3i. Minus times plus 5j, we have minus 5j. Minus times this, we have minus 7k. Can you see that? So now the next thing now is to just match the one that have the same alphabet together, the same direction together. 2i minus 3i. Of course, I will have minus I. You get that? Yeah, fine. So the second one too, 3j minus 5j, I will have minus 2j. Then 5k minus 7k, definitely, we are going to have minus 2k. You can see that. So just like a subtraction, just like, you know, if it's addition, we take them direction by direction. So the same thing is also applicable to when we have subtraction too. So I will leave the remaining one, the fourth one, for you to just the simple exercises. How are we going to do that? The first thing you are going to do, use 2 to multiply what we have in A, then use the same method. The minus must affect everything we have in the bracket, the one we have in the B rather, then you just find the values of each of them. I hope you are following it, right? Yeah, good. Now, that's all about what we have for addition of vectors. Okay, let me solve one more example. I think we have one question from the past questions here. So let's see the question together. In some problem, you may not have the same directions. Maybe they have different directions, but just follow the same process. Let's look at this problem. Let's look at this one. Marker. Yeah. This is almost done. It has been filled, right? No. That's not been filled? Let's look at this question 2. Find A plus B and a minus b if a vector a equal to 2i plus 5j and vector b is equal to 5i plus 3k. So now we have to find the value of a plus b. Okay, let me just, it's two questions. Let me just write them together so that we have a here today. So a is equal to 2i plus 3j minus 2k, and we have b to be minus 3j plus 2k. So now, this is another example. So now, let's see how we're going to do this together. Let's see how we're going to do this together. What is the one that you feel? Okay. So now, look at this question. Find a plus b. At the same time, we have to find a minus b from these two sets of vectors. So let's look at this for the first one. We have to find a plus b, right? So a is 2i. I'm firstly looking for the a plus b, 2i plus 5j, then plus b is 5i plus 3k. You know, I told you, just match the one that have the same direction together. If you look at it, I for I. So 2i plus 5i, definitely I will have 7i, right? But this is j, this is k. Can we add them together? Definitely no, because they have different directions. So that means I can just have 5j then plus 3k. So please don't confuse yourself about this one. Don't not say you are going to add them. Do not add them because they are not the same thing. Are they being they are the same now? I can just mark them together, but here they are not the same. So now 2i plus 5i, and we have 7i. So 5j, there's no j here. So that's why we have 5j then. K is here, but there's no k here. Then that's why we have 3k also. Now, we have to find a minus b. So my a is 2i plus 5j, right? Then minus our b is 5i plus 3k. I will still follow the same process. Using this minus to open the bracket of this one, that means that we have 2i plus 5j minus times this, I will have minus 5i minus times 3k, of course, I will have minus 3k. So now, still the same thing, 2i minus 5i. Definitely, we are going to have minus 3i, right? Then I will have plus 5j, then minus 3. You can see how we do that. I hope you are getting it right. Yeah, nice. So now, which other one again? So I hope you can solve the second one yourself, right? Yeah, good. The second one, we are given A, we are given B. Just do, okay. Let me just do that one too, so that you can have a better knowledge on these vectors. Let me use the same demarcations. I'll start to find A plus B at the same time A minus B. So the first one, I want to find for the second one rather. So A is 2i plus 3j minus 2k. So plus my b is minus 3j plus 2k. I will still match them together just like the way I do the first one. So 2i, you can see there is no I here. Can you see that? There's no I. So that means I will just have 2i. So this is j. You know, I told you if plus and minus come together here, of course it's going to become minus, just like this one. But you know, if plus affect this one, it's going to turn to minus. And if plus times plus is equal to the plus, that one doesn't change. So now 3j minus 3j, of course, we are going to have 0j, right? 0j minus 2k plus 2k, we are going to have 0k as well. So that means the only result that we have here is 2i. I hope you are getting it, because 2i is only the one that survived here. 3j minus 3j, that one is 0. Minus 2k plus 2k, that one is also 0. So let's see in the case of minus, I have 2i plus 3j minus 2k, then minus, my b is minus 3j plus 2k. So that means before we solve this problem, I'll firstly use the minus to open the bracket here. Hope you remember that. We are going to use the minus to open the bracket. That means here we have 2i plus 3j minus 2k. Now, minus times minus, of course, we have plus 3j. Minus times this, of course, you are still going to have minus 2k. So now let's match them together. It's only 2i that we have here, right? Because there's no other i. So here we have 2i. So 3j plus 3j, definitely you are going to have 6j minus 2k, you are going to have minus 4k. So meaning the value of a minus b here is 2i plus 6j minus 4k. So now we also have multiplication of vectors. So that one is what we call dot product, or we can call it scalar product. We call it scalar product, or we call it dot product. Multiplication of vectors, we call it scalar product, or we can call it a dot product. It's still the same thing, you understand? Just like how we normally multiply two vectors together. So let me tell you the law that guided this. If you have two vectors that have the same directions, is 1. If they have different direction, that one is 0. What are we trying to say? Let's say I have I dot I. You know, you can see they are the same, right? I dot I is always 1. Or I have K dot K, or we have J dot J. These three, they are equivalent to 1. That is, if they have the same directions. But if a vector have different direction, let's say we have I dot J, or I have J dot I, any cases, or I have J dot K, or I dot K. Whenever we have all these, the result is always 0. That is, if a vector have different direction and you want to dot their values, the result is always what? Is always 0. You get that? So for example, let's say, for example, maybe I'm solving a problem. Maybe I have a vector of the first one, maybe it has I and J, and the second one have I and K. The only thing I need to do, I'll just make sure that the two of them are the same, then I can have the value to be in the appropriate way. You see, that's why we have many examples. This is made easy academia. You can go just try to share the videos so that other two can be able to learn. And don't forget to like, share, and also subscribe to our channel so that you can have many tutorials videos. Now, I'll be using this one to solve scalar products. So in some question, they might say find dot product. Some might say find scalar product, or some might even put the dots in form of the problem. So just make sure that you know this law. If I have I dot I, or we have J dot J, or we have K dot K, that one is equivalent to 1. But if I have either I dot J, or I have J dot I, or I have J dot K, or I dot K, that one is equivalent to 0. So let's see example. They say if vector A is equal to 2i plus 3j plus 5k, for example, and we are given B to be, let's say we are given B to be 2i plus 6j plus, let's say plus k, for example. So the answer has to find A dot B. So they can say find A dot, they can put it in this way, dot, or they can indicate it for you in Paul, they can say find dot product. Okay, instead of saying this, they can say find dot product of A and B, or they might say find scalar product. All those three terms are the same. You understand, right? All those three terms are the same. So now I want to find A dot B now. A dot B. Very simple and straightforward. How will I do that? So my A is 2i plus 3j plus 5k. Then dot, the B is at 2i These are 2i plus 6j, then plus k. So I'll just match them together. I for I, j for j at the same time, k for k. So now 2i times 2i here, of course, you are going to have 4i. You understand? Oh, sorry. You are going to have 4i squared. Sorry about that, please. So you don't need to waste your time expanding it. Wasting your time. You know, if I say I dot I is like I squared, and I squared is 1. If I say k times k is like a k squared, and that one is 1. You understand? If I say j dot j, just like j squared, that one is going to be equivalent to 1. So I don't need to expand by saying this times this times this times this. That one is a wasting of time. Just match the one that have the same direction together. How? I for I, j for j, at the same time, k for k. You get it? Because I dot I is 1, j dot j is 1, k dot k is 1. But if I say I dot j, do you remember I dot j here is going to be 0. So I'll just multiply the one that have the same direction together. 2 times 2 here, and we have 4, because I dot I is 1. So 3 times 6, I will just have 18. Then 5 times 1, the value of this one is 1. So 5 times 1, we are going to have 5. Let me repeat this one again. 2 times 2. I and I for I is 1. I dot I is 1. So 2 times 2, and we have 4. I is 1. So 3 times 6, and we have 18. JJ is 1. 5 times 1, what we have here is 1 here. So 5 times 1, and we have 5. Because k dot k also is also 1. So 4 plus 18, we are going to have 22. 22 plus 5, definitely we are going to have 27. You can see the result doesn't have, is it working? The result doesn't have any I, J, or K because it's a scalar. But remember from the definition of scalar, we say scalar quantities are those quantities that have. No, it's working, right? So scalar quantities are those quantities that has only magnitude but no direction. You can see our result. Do we have any direction in these results? Yeah, nice. But then if you are looking for the, what do they call it? For the vectors, automatically there must be direction. So let's solve. It can come in form of a word problem. Let's look at these questions. Let's look at this problem. So here the question says a particle moving in the xy plane, undergoes a displacement given by delta r is equal to 2I plus 3j meter and a constant force equal to 5I plus 2j Newton. They now said find the work done. We have to find the work done. Now you can see it's in form of a word problem. You can follow the same process and the same method. Just what you remember, that's for the problem we are given the displacement by this symbol to be 2I plus 3j meter. That's how they give us in the problem. And we are given force also to be 5I plus 2j Newton. Now the question says to find the work done. If we miss our previous videos, so kindly work that I've know the formulas for work done. Do you remember the formula for work done? Yeah, force and distance. Yeah. So we know work is equal to force dot distance. So now the force we are given here is 5I plus 2j. The distance we have is 2I plus 3j. So I will only match the one that have the same direction together, right? Remember, I for I at the same time j for j. So now 5I times 2I, we have 10I dot I, and I dot I at 3 is 1. So 5 times 2, we are going to have 10. 2 times 3, we are going to have 6. So 10 plus 6, and we have 16. So force is Newton, and the displacement is a meter or distance, and we know this can be written as a joule because unit of work done is also what? Is also joule. So let's take a look at another problem from another area so that we can see how to make use of this approach. Let's solve another problem using, if it comes in form of a word problem. let's look at this one, a question from Kwara State University. The question says, this one is from Kwara State Universities. They said, we are given that if a force, if a force F equal to minus 5I plus 6J minus 3K, and displacement R equal to 3I plus 5K. Now the question says find F dot R. So look at this one too as well. It's also simple, but the only difference here is, if you look at the first one, it has 3 directions, right? And if you look at the second one, it has 2 directions. So this one is not like addition. You have to create it. If you have 3 in the first one, you must also have 3 in the second one. So how are we going to create that? So my F is minus 5I plus 6J minus 3K. So in the first one, nothing is missing there, right? So dot. In the second one, what I have there is 3I. You can see one is missing there. Which one is missing? Yeah, J. So I can just say plus 0J then plus 5K, so that I can be able to multiply them together. So follow the same process. I for I, J for J, at the same time K for K. So now minus 5I times 3, we have minus 15. You know, if I have I dot I is 1, I can only match those two that have the same direction together. Then 6J times 0, of course, we have 0. You know, 6 times 0 is going to be 0. Minus 3 times 5, you are going to have minus 15 as well. Minus 15 minus 15, you are going to have minus 30. So the only thing you need to take note here, under the scalar product or dot product, you can only match the one that have the same direction together. That is I for I, J for J, and at the same time K for K. So the next one we are going to is a vector product.